Hi everyone, my name is Muhammad Faisal AFIQ bin ZULHISHAM. I'm from Armary 41. Today I will presenting about Let 5 active filter. So let's learn about active filter. For active filter, we actually have two type of filter, which is we call active filter and passive filter. Then for passive filter, it's just a circuit with inductor and capacitor. It does not require any external power source and it does not use operational amplifier. But for active filter, it consists of resistor and capacitor and also operational amplifier to create the filter. So today we will be looking at low pass filter and high pass filter. This is a circuit for low pass filter and high pass filter. This circuit for low and high pass filter, and the circuit I just show to you is silent key low pass filter. So this is now I will be doing the simulation. The value of resistor and capacitor is already given to us from the lead sheet. So we just have to calculate the cut-off frequency. What we will be experimenting today is what happened to the gain, voltage gain. It's more like if it is less than the frequency cut-off, what will happen to the voltage gain, and it is more than the voltage at the frequency cut-off, what will happen to the voltage gain? So let's try with silent key low pass filter. This is a second order silent key low pass filter. It's called second order because we have two RC section. To simplify, we can just count how many capacitor are in the circuit. So like here we have RC section is after the 953 ohm. For resistor 1, it's made into capacitor. You can see this is one RC section we call. Okay, down here is after 1k resistor, 1k resistor into the capacitor, we call is RC1 section. So we have two condition, so we call it second order, or we can call it two pole silent key low pass filter. So this is the frequency cut-off we calculated. What happened to frequency at voltage gain if less than frequency cut-off? You can see I put it's less than frequency cut-off. After simulation, we can see that the voltage in and the voltage out is the same value. Voltage in and the voltage out is the same value, 2 volt. The voltage in that we give is 1 volt Vp, but the frequency is based on the table we calculated. So we get the voltage gain is 1. So since voltage gain is voltage out over voltage in, so we get 2 volt over 2 volt, so we get 1. So now let's try for 40.2 kilohertz, the highest. We change the frequency. As you can see, the voltage out is less than the As you can see, the voltage out is less than the voltage in, which is mean that the voltage gain is less than the 1. Okay. The voltage gain is less than 1 when it's more than the cut-off frequency for low pass filter. After we test it out with the different frequency, we make it easier to us to plot a graph which is the voltage gain versus frequency. So we will get the graph like this for a low pass filter. So this is the frequency that have been given, and we have been plot for the value we get. Now let's go looking to the high pass filter. It is supposed to be the same as a low pass filter. I will show you. This is a schematic circuit for high pass filter. We start off with for low pass filter we start resistor then capacitor. We start with resistor and then capacitor. But in a high pass filter we start from capacitor and then resistor. Also below here, from capacitor into the resistor. We call this second order because they have two section, one section and two section. So this is different for high and low filter. Now this is the value we calculated for the cut-off frequency. So now we start off with frequency 141.25 Hz. I will run. So as you can see, the output voltage is very small when the frequency is lower than frequency cut off. So it is inverted with low pass filter. Low pass filter, when the frequency is lower than the frequency cut off, the voltage is similar to the voltage in. We get the stable voltage gain. High pass filter, the lower frequency than cut off, the output will become small. So that's mean the voltage gain is less than 1. Now I will change the frequency. If we change this to the high frequency, higher than the voltage cut off. So let's try with the, you see now, with the 56.5 kilohertz. Okay, now 56.5K is more than the frequency cut off. The graph show, we can see the voltage output and the voltage in it looks like the similar, and the value is very close. And we try by different frequency to make it easier to us for create a graph for voltage gain versus frequency. So after we try all different frequency and we plot, we can get the graph like this. So this is the graph for high pass active filter. We can see there is different between the low pass and the high pass. The graph is opposite with the low pass filter graph. This is the circle I have been done for key low pass and the high pass filter. So conclusion, to demonstrate the use of operational amplifier in active filter, and also to build an analysis of the silent key to order and low and high pass filter design. I think that's all from me. Thank you for lending your ears and see my present. Thank you for all.